Last episode, vLLM made one model serve a crowd without buckling, but serving the model is only half a retrieval system. First, you have to find the right text to feed it. So, here's the question that powers every search box and every RAG pipeline. How does a computer know that two sentences mean the same thing when they don't share a single word? The trick is to stop treating text as text. You hand a sentence to an embedding model, and it hands you back a list of numbers, a vector, a single point floating in a few hundred dimensions. That's all an embedding is, a address in meaning space. And the addresses aren't random. The model was trained so that sentences with similar meaning land near each other and unrelated ones land far apart. The cat sat on the mat and a feline rested on the rug, share almost no words, yet they end up neighbors. Meaning became geometry. Once everything is a point, similar becomes close, and you measure closeness with the angle between two vectors. That's cosine similarity, 1 when they point the same way, 0 when they're unrelated, and it ignores how long the vectors are, so a short sentence and a long one compare fairly. Do that for every pair and you get a similarity matrix, a grid where each cell scores how related two sentences are. The diagonal is always 1 because every sentence is identical to itself. The bright off-diagonal cells are where the magic lives. That's the model telling you which sentences are secretly about the same thing. Let's make it concrete with 6 sentences, 2 about pets, 2 about cooking, 2 about finance, and watch the geometry sort them. To keep this reproducible to the digit on any laptop, we seed a small deterministic embedder instead of downloading a model. The comment shows the one-line swap for real sentence transformers, all MLflow, whose API is identical. Each sentence becomes a vector, and then this one line does the real work. vL2 normalize every vector so its length is exactly 1. Once every vector sits on the unit sphere, cosine similarity is just a dot product, no division, no surprises. So the whole similarity matrix is M at M bod T, one matrix multiply. Row I, column J is the cosine between sentence A and sentence J. The diagonal comes out 2 once because a unit vector dotted with itself is 1. Then for sentence 0, we mask out itself and take the argmax of its row, the highest scoring neighbor that is in the sentence itself. That's a nearest neighbor lookup, the exact operation a vector database runs millions of times a second. Run it. The matrix prints and the nearest neighbor of the cat sat on the mat comes back as the other pet sentence with a cosine around 81, well above its score against the cooking or finance lines, which sit down near 0. The seed makes that number land the same on your machine. And the figure says the same thing the terminal does. The bright cell in the top left pet block matches the 0.81 reconcile printed in the log, and the dark finance versus pet cells match the near 0 scores, figure equals terminal, meaning made visible as heat. Text is now points, and find the relevant one is now find the nearest point, which is great until you have a million points and a brute force scan gets too slow. Next episode, FAISS, the index that finds nearest neighbors in milliseconds.